Big data is a data set that exceeds processing capacity of conventional database systems. What we try to do on top of it is that we try to develop algorithms that can work on it in reasonable time so that we do not have to repeatedly sample the data points, and we can work on the entire thing in a well documented way. We should be able to create algorithms on top of it and explore it. We should also have something that has something which can bring the computation to data. So a distributed file system kind of storage where you can work on clusters of data points, and that way your computation can be directly on the data points and it can be faster and efficient. We have a lot of information, we have a lot of data. So the analysis is right now focusing on asking the correct question for the data. This itself is called the big data approach. A major ethical problem which is occurring because of such algorithms and provisions in today's society is that of privacy and security, because you can easily infer sensitive information on the person that we collect, or that we if we collect in a population, and because it leads to important insights about individual people, and hence it is very easy for authorities to socially stratify the people, and hence like take advantage of this big data predictive analysis. There are three main sections of this big data which we can focus on. The first is volume, second variety, third velocity. In the volume section, what we focus on is that we keep most of our data so that we don't have to throw or discard it. We try to keep the storage of it scalable. That means that we can try to work with different types of storage systems, like distributing it. We can also have a data to be queried, and the data itself can be structured or unstructured. And by that I mean that it can be organized in a defined data model or not. By variety, I'm I mean that you can have a possibility to clean the various types of data. So your data can come from a store, from a source, and it needs to be processed. So it might lose some information. So the RDBMS system is not the best source, even when it is tidied up. So an alternative to that is that you can use network databases in graph database, or you can have XML data, but which has dedicated XML format storage. RDMS often returns more than required in the computation. So you should try to decide what fits your application best. We can also have semi-structured NoSQL, which is flexible and it provides enough structure to organize, but also does not require any schema. We have another video which covers why NoSQL is really advantageous. And the last section is velocity. So this is the rate at which the data is input and output. So the throughput decides the rate at which it is input. So the data is treated to decisions before it is accepted and stored. Sometimes it is not possible to wait for a report to run completely, so we can actually stream the data, and applications mandate immediate response from the information. So this need for speed is developed sometimes in key value types of data stores. And there's also something called column database, which is an example of RDBMS. Actually, it processes faster than the row database that you are more used to seeing. So we can have an advantage of big data in querying the scalability. Basically, this means that if you have a normalized database, you can increase the querying scalability because it requires less space on the disk. Um, you can process more things like update or delete faster. And the advantage of this is that any query can be run. The disadvantage is that join is often expensive on the RDBMS system, and especially if it is millions of rows. So a solution to this is that you can denormalize the database. So do clever joins before you implement your main query. You can also change the schema of your database from a normal linear database. You can convert it into a star. So your linear form of the RDBMS storage will be reduced to a fact table, which can have links that are the foreign keys to every other table inside that database. You should also be working with writing scalability, which is like the insertion should not time out for any kind of record that you're trying to input. So we often work with queuing, which means that you can have a queue of all your inserts, and the batch will process this to at once, like all at once. So we won't have to face the problem of having a timeout per insert command. So another strategy to escape the timeout is using sharding. You have multiple database servers in this case, where your subset of data is partitioned. So the application will find the shard for each key, basically the database for each insert, and monitor the splitting of the big database into smaller shards and keep a track of all the shards that are inside your network. So a challenge for RDBMS over here is that you have fault tolerance, because as the number of machines increases, the chance of damage increases. Second, you have code complexity with other applications because the distributed nature of data is not abstracted. It is definite, it's defined before you know the schema. You also have lack of human fault tolerance because like you cannot afford to have a system which can be manipulated by a user. So your data should be immutable, and you need to have a maintenance of code. So we need to, for example, with sharding, we need to have clever algorithms that can work and be reworked later on if required. So with big data, the main properties that we are trying to work on, and as we'll see in other videos like that of our Lambda architecture, we will focus on improving these properties. So first, big data property is that self-aware. It should know the shard, it should know when to replicate, where to distribute. It should be immutable because users should not be able to destroy the good data. The queries that are general and ad hoc can be handled by this big data. It should be scalable based on the performance and dataset size. It should also be extensible for large scale migrations, because if you want to improve on the functionality of the dataset, it should allow that. It should also have minimal maintenance, so you rely on simple code. As we will see in the Lambda architecture too, there's a trick to remove the coding requirement from the batch layer. So we have a speed layer for that complexity. And lastly, it should be debuggable. So you should be able to trace the route to determine the exact place where you can find the error.